Okay, we are reviewing central angles and arcs when given circles. Okay, so for numbers 1 and 2, it says, if an angle is given, name the arc it makes. If an arc is given, name its central angle. Okay, so let's go ahead, I'll zoom in. Let's look at number 1. Okay, so it gives us arc ST. Okay, so this is a minor arc, starts at S, ends at T because there's only 2 letters. Okay, so if it's giving us that arc, then we need to name its central angle. Well, the angle that those 2 endpoints create would be angle 1. And there we go. Okay, for number 2. It's wanting the major arc for angle 2. Okay, so here's our angle 2, that's what it's giving us, but it wants the major arc. Okay, we could do the minor arc, that would be just ST, but we still have those 2 endpoints. The major arc is the bigger one. Okay, so it's going around, it's going through another point, which in this case is going to be R. I should have done that in purple, oh well. So we have this arc right here with those 2 endpoints. Okay, and we name that S, and then it goes through R, ends with T. You also could have started with T, goes through R, ends with S, same thing. Okay, so remember that the major arc, 3 letters. In fact, let's make that note on our paper. So whenever it's asking for a major arc, we use 3 letters to name. Okay, beautiful. Alrighty, so for numbers 3 through 6, it's asking us to solve for x. Assume that lines which appear to be diameters are actual diameters. Okay, just reminding us what a diameter is. That's not the most perfect circle, but a diameter is from one end of the circle straight across to the other end. Okay, and we know that a diameter is 180 degrees. The whole circle is 360 degrees. Okay, so that's going to help us solve for x, those 2 little facts. Alrighty, so we're trying to solve for x. Let's go ahead and figure out where our x is. Well, our x is located in that -7 angle right there. Okay, so what we can see is these 2 angles, okay, make up where my x is. But then I also have these angles. Now, whenever these angles create a perfect x, and they're right across from each other, so this 115 and then those 2 angles put together, these are called vertical angles. Okay, where they create that x and then they're across from each other. Okay, this helps us because vertical angles equal each other. Okay, so what we can actually say that's going to help us solve for x here is if this angle is 115, then these 2 guys added together are also going to equal 115. Okay, so we can take this angle, 115, set it equal to these 2 guys added together because they're both those angles. So I have 73 and then added, but technically it's a negative, so minus 7x. Okay, and that's how we can set up our equation to now solve for x. On my side with my x, there's no like terms I need to combine, so I can go ahead and just start getting rid of terms. The one that's farthest away from my x is this positive 73. I get rid of it by subtracting 73. Okay, so now I have 115 minus 73 is going to give me 42 equals negative 7x. Okay, and my last step to get my x by itself is to divide by this negative 7 since it's being multiplied. So we get x is equal to 42 divided by -7, which gives me -6. And there we go. Okay, let's look at number 4. So again, we're solving for x, so let's identify where x is. It's right in this angle, right there. Okay, well, it gives me these 3 angles, 1, 2, and 3. But we see that all 3 of these angles create that diameter that we were talking about. Okay, well, if a whole circle is 360 degrees, we know that half of the circle, or just the diameter, is 180 degrees. Okay, so what that means is, again, we can take the information it gives us, even the one with the x, and we add them all together, and they're all going to equal 180 degrees. Okay, so take my first angle, which contains my x, 7x plus 8, plus 64, plus 73, and it all equals 180 since it's that diameter, or half of my circle. Okay, well, now I look at my side with my x, and I do see some like terms that I can combine. See some constants, or just numbers, that I can combine. So I can take 8 plus 64 plus 73, and that's going to all turn into a positive 145. So now on this side I have 7x plus 145 equals 180. Okay. Now I can solve for my x. So farthest away from my x is this positive 145. Get rid of it by doing the opposite, negative 145. So now I have 7x is equal to 180 minus 145. Gives me 35. And one more step to get my x all by itself. Opposite of times by 7 is divide by 7. So I get x is equal to 35 divided by 7, which is 5. And there we go. Okay, number 5. Okay, so we're solving for x, and we actually have x's in 2 different places. Okay, so seeing the information that it gives us, we actually have a couple different options that we could do. We could take this angle, that angle, and that angle, and they all add up to that 180. Or we see that these 2 angles, this angle 125, and then these 2 angles are vertical angles, so they equal each other. Okay, let's see, just because I think we want more practice with the vertical angles. So again, this angle, my 125, and these 2 angles, 54 and 9x minus 1, they create these vertical angles, meaning they're across from each other. Okay, well again, vertical angles always equal each other. Okay, so I can take 125 is equal to 54 plus 9x minus 1. So let's go ahead and write that out. So I have 9x minus 1 plus the 54 is going to equal that other vertical angle, 125. Okay, now I can go ahead and see if I need to combine any like terms on my side with my x. I do. I can combine the constants, so I have -1 plus 54, or 54 minus 1. So that's going to give me 53. So now I have 9x plus 53 on that side equals 125. Okay, and a couple things I need to do to get my x all by itself. So I need to get rid of my plus 53 first. So I do that by subtracting 53 from both sides. Get 9x is equal to 125 minus 53 is 72. Okay, then my last step for getting x all by itself, opposite of times by 9, is divide by 9. So my final answer, x is equal to 72 divided by 9, which gives me 8. And there we go. Beautiful. Alrighty, number 6. So this one's actually pretty simple. So solving for x, and it's actually our x is in the arc this time, so it's that arc. But we know that the measure of an arc is always equal to the measure of its central angle. Okay, so knowing this one's actually a pretty simple equation to set up. So we know that this arc, 7x plus 12, is equal to its central angle, 75. Okay? No like terms I need to combine, so I can just start getting rid of things. So I need to get rid of plus 12, so I can subtract 12. So I get 7x is equal to 75 minus 12, gives me 63. And then my last step for getting my x all by itself, opposite of times by 7 is divide by 7. So 63 divided by 7 gives me 9. And there we go. Okay, so a few different rules to remember. Okay, so vertical angles, meaning when they create this x and they're across from each other, they equal each other, which we saw in numbers 3 and 5. Okay, they equal each other. Okay, if they create a diameter, that straight line, half of our circle, that equals 180 degrees. And then the measure of an arc is equal to the measure of its central angle. Okay, so all those rules helped us solve for x there. Okay, so let's go ahead and do numbers 7 and 8. So for 7 and 8, it's asking us find the measure of the arc or central angle indicated. So now we're not just solving for x, we're actually finding the measure of that arc or angle. Okay, and then it says, again, assume that lines which appear to be diameters are actual diameters, so half of our circle. And let's look at number 7. So we're trying to find, our end goal is the measure of minor arc NJ. Okay, so we're trying to find the measure of that arc. Okay, and we don't know what that is because the angle that it's equal to has an x inside, but we can see that the measure of the angle we're looking for, which is going to match up with its arc, and then the angle that another angle that it gives us, even though there's an x in that one, they create that diameter. Okay, well again, the diameter of a circle is always equal to 180 degrees. So now we can take this guy, which is what we're going to look for, and the other guy, add them together, set it equal to 180, and solve for x, which is going to help us find the actual measure of that arc. Okay, so let's go ahead and do that. So I have x plus 44, that angle, plus my other angle, x plus 140, is all equal to 180. Those two angles added together create that diameter, so they equal 180. Okay, well there's a couple different like terms I need to combine. First I see two x's, one x plus another x is 2x. And then my constants, 44 plus 140 is going to give me 184. And again, it's all equal to 180. So now I can go ahead and solve for x. Okay, so the first thing I got to get rid of is this plus 184. I do that by subtracting 184 from both sides. Okay, so I get 2x is equal to negative 4. And then I can find my x. Opposite of times by 2 is divide by 2. So my x is equal to negative 2. But remember, that's not our end goal. It's not asking us to solve for x. It's asking us to find the measure of this arc. Okay, well again, the measure of the arc is the same thing as the measure of its angle. So we're just going to take this negative 2 that we found for our x and plug it in to our x, which is in that central arc. So now I have negative 2 plus 140 equals what? 140 minus 2, 138. Okay, so our end goal, the measure of arc NJ, which correlates with the measure of its central angle, is equal to 138 degrees. Beautiful. All right, let's do that one more time. So let's see what it's actually asking us to find. We want the measure of arc JF. Okay, so JF, so this guy, which is going to equal this angle in there with my X. Okay, well, I don't see any straight diameters, but it gives us something for all of these angles. So what we can do, we know that this angle in red that we're looking for, plus that angle, plus that angle, plus that angle, plus that angle, gives us that full circle, which, again, full circle is 360 degrees. Okay, so what we're going to do to first find X so that we can plug it back in is to add all of these guys up, set it equal to 360, and solve. Okay, so let's do that. Let's just start with our red guy. So I have X plus 66 plus my next guy, X plus 71 plus 150 plus 65, 65. And then this starts with a negative, so technically minus 3x minus 3, and it all equals, you might want to see that, 360. Okay, looks really long, but all we have to do is combine like terms. Okay, so let's find our like terms. First, I'm going to start with my x's. So I have 1x plus another x minus 3 of those x's. Okay, so that's going to give me 2x right there. 2x minus 3x is actually going to give me negative 1x. Okay, now I can add up all my constants. 66 plus 71 plus 150 plus 65 minus 3, and I'm actually just going to put this all into my calculator. So 66 plus 71 plus 150 plus 65 minus 3, and that gives me a positive 349, and it all still equals 360. Okay, so now I can go ahead and start solving for x. So the first thing I got to get rid of is this plus 349. Do that by subtracting 349. Whoops, didn't mean to use red. Oh well. Okay, so now I have negative x equals 360 minus 349, positive 11. Okay, now remember, technically this is saying negative 1 times x. Well, the opposite of times by negative 1 is divide by negative 1. So we get x is equal to negative 11. Now again, that's not our end goal, that's just going to help us solve for our end goal. So we found that x is equal to negative 11. What we're actually trying to find is the measure of this arc, which is going to equal the same thing as the measure of that angle. So we just take this negative 11, now that we know that's what x is, plug it into where we need the x in that arc, and we can solve. So now I have negative 11 plus 66 equals 55. Okay, so we know now that the measure of arc JF is equal to 55 degrees, since it's the same measurement as its central angle. All right, those are your notes. There's an assignment that goes with it.